have made our lives better. None drives home the point about lithium-ion batteries. Everybody who is sitting here with a cell phone has a lithium-ion battery in the cell phone. The cameras and everything that are around here have lithium-ion batteries in them. So, why would we then not make sure that as a country, we are about to go and mine lithium at Ewoya, but we have no plans of beneficiating this lithium? And if chemists start talking about this, you start hearing that this person belongs to party A, this person belongs to party B. If we don't start looking at beneficiating a lot of these things, the lithium that will be mined at Aoya will come back to us in a finished product, and most people who live in the Salt Pond area will not be able to buy the product. They are going to come back in the form of electric vehicle batteries, and by then we would have stopped using these internal combustion engines that have petrol in them, because there will be no more petrol to put in them. So, if we look at this, Ghana currently has manganese in abundance. We are about to mine lithium, and we have graphite that is in the Upper West region that is also going to have to be beneficiated. These are the things that go into our lithium-ion batteries, either lithium iron phosphate batteries or lithium manganese oxide batteries, and the lithium manganese nickel cobalt batteries that are the top batteries that we have here. So already you can see where chemistry comes in. When you take any of these things, they come as ores, but the processes that extract these chemicals in the form that they are used in making batteries is laden with acid-base chemistry. The critical part that we seem to be missing, especially on the continent, is that storage of energy in small devices are just the tip of the iceberg. If we're going to get ourselves out of the issues of energy that we don't have, power that we don't have, we have to start storing energy in large batteries, just as we have in this slide. So solar power, wind power, all getting stored in batteries so we can redistribute this. We can win a lot of villages of the national grid and supply them with reliable batteries if we learn to do some of these things. One of the easiest way to do this is what is called a flow battery. And I'll show you a picture of what a flow battery is. Flow batteries are generally made from vanadium or iron chrome electrodes. And these are then packed in such a way that they can store large amount of energy in a manner that I've gone a bit too far. Oh, okay. In a manner that the storage energy is, I think a slide has gone off my series, but suffice it to say that we're going to have to start storing these large amount of energies in big storage batteries. The next thing that I want us to start looking at is how has chemistry served humanity. In a lot of instances, the benefits that we've have come with problems. The first place that I want us to touch is the energy space, how we generate energy and the environmental issues that come with it. Chemistry has served us in the health and allied industry. The drugs that we take, some of us take every morning, every evening, and at times even in the afternoons, they are all laden with chemistry. How do we get food to eat or even process food without having to have chemistry with it? The packaging that we have for our foods are all polymers that are non-toxic to people. So these are some of the key things that chemistry allows us to do. But it is obvious that chemistry has also created problems for us. Not too long ago, we used to have leaded petrol. Today, when you go to buy petrol, you talk about unleaded petrol, primarily because tetraethyl lead that was used in petrol as anti-knock was beginning to cause heavy metal deposition of lead, and the environmental chemists amongst us will start educating us that environmental problems that we have with lead poisoning and a whole lot of things come from that. So the chemists pivoted to start looking for alternatives for these additives to petrol, because these things get put in the petrol to prevent your cars from knocking. The first port of call was methyl tertiary butyl ether, MTBE. And sooner rather than later, it became obvious that because these are volatile organic compounds, when your engine starts firing and these volatile MTBE evaporates, it ended up in water bodies in places like California. So MTBE was also labeled bad and discarded. So if you sit in some of these level 3 courses, your professors start in inorganic chemistry start preaching to you about organometallic compounds. Metal and organic compounds together. That's where we tend to start looking at how these anti-knocks could replace the ones that we had before. So we then started looking at classical organometallic compounds like ferrocene, methyl cyclopentadienyl, manganese tricarbonyl, a long name. The long and short of it all was that these were safer alternatives as anti-knocks for petrol that we currently use. So if you go to Shell's website now, they will be advertising that they add organometallic compounds to their petrol to make them efficient. These are some of the benefits that we're looking at. So let me turn to thermal power generation, which is one of the things that has created all the greenhouse gases that we can think of. And generally, when we start talking about our energy generation, our energy power generation comes from coal in the main because it is cheaper and it is abundant. But when you use coal to generate electricity, the obvious output that comes from there, because you're burning a hydrocarbon, is carbon dioxide. This slide here gives you a sense of the deaths that come with using these as sources of power. And the number that I want to highlight here is that for coal, we're talking about an average of about 264 deaths as a result per year, as a result of the coal that we use. Whereas if we use cleaner energies like wind, we have less than 1 death per year by this clean energy. So obviously, if we don't start looking at cleaner sources of energy and go on to use this, the environmental issues that I've highlighted will continue to be with us. So the primary chemical that I want us to keep in mind as we go is carbon dioxide. And everybody who knows the chemistry of carbon dioxide knows that it is one of the difficult molecules to convert to anything. Hence, we need brighter minds, better technologies, innovations to be able to get these nuisance out of our energy space. The picture that I've shown you here is a classical picture of electricity generation in South Africa. So you have a coal power station, and that coal power station is literally spewing things into the atmosphere, which are generally carbon dioxide, nitrous oxide, at times even sulfur oxides, because coal has sulfur and nitrogen containing compounds. So, if the advice that South Africa has been given is that if you want to solve these problems, then you have to start looking at cleaner sources of energy. Why? Because in where are my IT people? No, the slide was not moving. Yes. Okay. So what I'm driving at is that by generating energy or electricity from coal, the immediate area around some of these coal power stations are such that the amount of oxygen that usually is in the environment for us, which is close to 21%, actually drops to 6%. The amount of carbon dioxide which is in the atmosphere, which is around 0.03%, shoots up to 13%. So 2 of the critical gases that you need for life, whether it's human or plant life, you've completely changed their balance in the atmosphere. So if you don't find ways of either capturing this carbon dioxide in the before they get into the atmosphere, you can't use your coal to generate power because you are endangering everybody's life. So, I think the system stuck? Or So if we're going to have to deal with some of these things, our approach to three very critical molecules that control a large aspect of our lives would have to start changing. The three molecules are hydrogen, ammonia, and carbon dioxide. So why would we need to start looking at how to control the production of hydrogen? Hydrogen is currently produced in large quantities from natural gas. Natural gas is 65% methane. So the process to make large quantities of cheap hydrogen is actually through a process called pyrolysis. And pyrolysis in simple, plain English is burn this thing, heat this thing until it gives up. So if you are going to heat methane in the presence of oxygen, obviously you are going to produce carbon dioxide. Right? So the first approach to this is to start classifying how you produce hydrogen. The hydrogen that is produced from either coal or from natural gas is classified as either black or brown hydrogen. So now you're going to see hydrogen in different colors by the time I finish this section of the talk. So black or brown hydrogen means that you burning methane to produce hydrogen and carbon dioxide in large amounts. If you are then able to capture the carbon dioxide through a process that will not get the carbon dioxide into the atmosphere or the carbon dioxide into the atmosphere, we call that blue hydrogen. And blue hydrogen has now developed to a point where about 85 to 95% of the carbon dioxide that is produced this way is captured and not get the carbon dioxide to go into the atmosphere. The next stage where you can produce hydrogen without any trace of carbon dioxide is what is termed green hydrogen. Green hydrogen production is old chemistry that we learn in high school, electrolysis of water. So if you're wondering what electrolysis of water is, it's literally splitting H2O into the component atoms. If you take oxygen out as an atom, hydrogen out as an atom, they will then combine to give you dihydrogen and dioxygen. No carbon in the vicinity. But the cost of producing this type of hydrogen now has to be within the means of society. It's not that we don't know how to make green hydrogen, but the gray hydrogen and black hydrogen that we make is so cheap that we can use it anyhow to solve our problems. So the challenge now is for us to go to then how to make green hydrogen. But you can also make hydrogen without producing carbon dioxide from natural gas through this same pyrolysis, but then the byproduct for this process is carbon that is deposited. Plain carbon, carbon black. This is what is now known as turquoise hydrogen. So if you're looking at Ghana as a country, This thing is not moving. If you can move mechanically from there, I will say next, and you can do that for me. That works. Yeah, so go back a couple of steps. So if we now then look at turquoise hydrogen, the technology for turquoise hydrogen has developed to a point where this plant that is in Nebraska in the US is already producing turquoise hydrogen without carbon dioxide coming with it. If we then can start looking at people coming up with all sorts of shades of hydrogen, red hydrogen, that in the UK they're producing with nuclear power, because now you need to have a clean source of energy to break this water and hydrogen into. Such that there are now several projects, big projects on the continent, that by 2030 up to 2035 will be producing large amounts of hydrogen for basically the European market. So again, we have the opportunity to produce this as we produce oil on the continent, but this time for Europe, because the African continent has enough clean energy sources, solar and wind, to allow us to do this. If we look at, there are 9 such projects that are there. The first one on the previous slide actually is the biggest on the continent in Mauritania. We're not talking about an African superpower. Mauritania has potential investments of $74 billion going into green hydrogen production. And I think this is where our conversation should start. If we look at Ghana and the Tvucc gas that we have, can we have a plant that makes turquoise hydrogen, because we will be producing hydrogen without putting things in the atmosphere. Okay. Next slide, please, if you can move it for me. Next slide. Next slide. Yeah, this is the UK story that I've just spoken about. Please go to the next slide. Yeah, the question that I've asked right now, I don't think it will. Yeah, I don't think it's working. So this is the question that I'm posing for Ghana, that can we make use of the natural gas that we have in abundance? And let me tell you a little story that I heard from Ghana Gas, that the LPG that you put in your cylinders to cook is not methane. The gas that we use in cooking is butane, pentane, etc. The higher amount of this, which is methane and ethane, is what we pipe to go and power our thermal plants. So instead of using this to power our thermal plants, we can actually use it to produce hydrogen and use the hydrogen cleanly compared to the natural gas, which, even though it's meant to be clean, is not as clean as they ought to be. Next slide, please. So the second molecule that I want to talk about is ammonia, and I'll be quick. Ammonia, next slide, has a history that we are all aware of. And that part of the history of ammonia production is the Haber-Bosch process. We learned about this in high school, industrial preparation of ammonia, etc., etc. Now, ammonia is being prepared either as green ammonia from green hydrogen or blue ammonia from blue hydrogen. And not only is ammonia now a fertilizer, but it is a hydrogen storage molecule. And if you go to the next slide, it's working now. Okay. Yeah. The next slide is literally technology that has been developed by Aramco and SABIC, two companies in Saudi Arabia, where they make blue ammonia from blue hydrogen, and blue hydrogen literally being natural gas that they make ammonia, hydrogen from, and capture the carbon dioxide. To make this a commercial process, they now ship blue ammonia to Japan, where they then decouple the hydrogen to give you hydrogen to power their plants. So these processes are there. People are now talking about circular ammonia economy. And this is basically taking, making blue hydrogen, converting the blue hydrogen and nitrogen to ammonia, and taking that through all sorts of areas of apology, I think I pressed the wrong button. Yeah. So this is a real life case of blue ammonia that is being shipped from the Middle East to Japan. And that is your circular economy. Such that now places like the US, they have roadmaps for ammonia, just to make sure that each one of these advantages that can come from ammonia is now in place. So, carbon dioxide. What are the opportunities for us to deal with carbon dioxide? And I've said that if you then have setups that have carbon dioxide coming out of it, there is now technology to capture the carbon dioxide, clean it up, and take it through hydrogenation of carbon dioxide. And that hydrogenation of carbon dioxide will make you molecules like methanol. And in fact, in some cases, this is a project that we run at the Botswana Institute of Technology Research and Innovation a couple of years ago, where we've developed a catalyst that is very competitive with the commercial way of making methanol from carbon monoxide. But this time, we're making the carbon dioxide from the methanol from carbon dioxide. So carbon monoxide versus carbon dioxide, this would allow us to then make use of the carbon dioxide that is coming out of any establishment. The important thing here is that it is even more selective. Our process is more selective towards making methanol. And the trick here is that if you look at this equation, which simply means carbon dioxide and hydrogen producing methanol and water, the water normally kills your catalyst. But the innovation that we have is such that the catalyst has support that mops up the carbon dioxide. So what we need to do is to scale this up to commercial quantities or commercial production. This is basically how capturing of carbon dioxide and taking it to methanol is. You don't need to read the details of this. But also to give you a real life example of how this is practiced. This is a plant in China. So when you hear that China is the second most polluter, they have devised ways of capturing their carbon dioxide to put the carbon dioxide to use. So this is the, there's a fair bit of chemistry here where we talks about indirect and direct capture of carbon dioxide. The indirect is where you take carbon dioxide. In those who teach advanced organometallic chemistry, you talk about something called water-gas shift reaction. This is your reverse water-gas shift reaction that produces carbon monoxide from carbon dioxide, and you convert it to methanol because we know how to do carbon monoxide to methanol reaction. The problem is that you have an equilibrium that is reached in that indirect reaction. The direct reaction that is being developed, you can continue depending on the conditions that you apply to produce more and more methanol. Okay, and this is also a plant in the US that converts carbon dioxide to methanol. I want to quickly run through a few slides that even when we start looking at these fossil fuels with the problems that they give us, there will be a time when there will be no fossil fuels. So for us to maintain the lifestyle and the comfort that we have, we're going to fall back on what nature gives us, which we can sustainably produce. That is biomass. So if you see this slide here, I come from the Kwaibibrim district. Anybody who knows that knows that there is an oil palm project that was set up in the 70s at a place called Kwai. So there are outgrowers in the whole area that make a living out of growing palm and harvesting the palm. This is a women cooperative on my way to my village in a place called Abem. That was on the front cover of the American Chemical Society Chemical and Engineering News in 2010. So why am I telling you this? That a lot of the chemicals that we get currently from petrochemicals can actually come from biomass if we get our technologies and processes right. The obvious one is what we know as biofuel. Biofuel is a esterification. It gives us esters, but we can also do hydrogenation of these plant fatty acids straight to diesel as we have it now. And there's a plant in Singapore that makes this clean diesel from palm oil. I'll skip the chemistry of it. It's obvious that for this you have to cut off the oxygenates and just get your chain there. But there is also a whole slew of chemistry that byproducts that we have from these plants can be explored. Everybody knows that biodiesel production produces glycerol. What do you do with the glycerol? This is a number of things that we can produce from glycerol. That currently comes from petrochemicals. It will come from our plants as well. For instance, if you look at palmitic alcohol can come from this fermentation process. This is a natural process compared to the chemical process that comes from petrochemicals. So we still have ways of dealing with things that will not will give us. Ethylene currently comes from petrochemicals, but we can make ethylene from bioethanol. It is dehydration of alcohol. Dehydration of alcohol gives you olefins. And if we have an avenue to do that, all these myriad of things, there are polythene that we throw away, we can still make them, but make them sustainably. So this is the last but one slide. So those of you who getting tired of my squeaky voice. Yeah, so if we look at what we've gone through, we have know-hows from our petrochemical industries. This is things that the Germans mastered for the Second World War, taken over by apartheid South Africa, and it's now being used all over the world to do hydrogenation of carbon monoxide to all petrochemicals that you can think of. We can use that process to start producing carbon monoxide from biomass. But we can also use the fermentation route, which we have just highlighted a few minutes ago, in order to avoid having to use the petrochemical route to do this. And this is what is now referred to as second-generation biofuels. There are even third-generation biofuels that are coming. So, in conclusion, I want you to see that even when we look at biomass, the myriad of things that I showed that came from petrochemicals, they are also here. So our lives will not change a bit if we learn to do things sustainably. And on that note, I hope I have been able to give you an idea that whatever bad names that people have for chemicals, a lot of the things that I've highlighted now, for now, and even in the future, revolves around chemistry and chemicals. But we're going to have to learn how to do these things sustainably, not in a green way. Green is the stream of sustainability, but certain things that we do that are green are not sustainable. So let us do things sustainably, and let's also look at how Africa and our own Ghana can be part of this conversation in a meaningful way, because a lot of the inputs that will make Europe live sustainably actually are going to come from us. Let's take advantage of the opportunities. And those of our brothers and sisters who are from industry, this is the question that I want to leave with you. And the academics who teach people to go into industry, that is the chemical industry in Ghana working towards a net zero set of processes, because that is where our sustainability hinges. Thank you very much for listening to me, and apologies for the breaks that we've had. Thank you.
Thank you very much. Ladies and gentlemen, I think we can do it one more time for our keynote speaker, Professor James Dakwa, for your insightful presentation. Please, high table personalities take back their seats. Yes, I think there will be opportunity. There will be an opportunity for us to maybe engage with our keynote speaker. If that will be possible, maybe there are a few questions some of us would want to ask. Because, yes, it looks like the atmosphere over the years has been poisoned with the idea that chemistry perhaps may be doing more harm than good. But yes, we know it is the reverse. But there are still challenges. In his conclusion remarks, he says that we should ensure that the craft is practiced sustainably. Well, we have issues, and I would ask you about that along the line. Yeah, so There's no doubt about the fact that chemistry is a central science. Not just the central science, it's the center of everything in this world. Not until the chemists were able to develop the ink could the historian jot down or document history. Every other thing was oral history. And you remember even how we saw the skies move into the place where it is today. When we were kids, there was a story told of an anabre will be like an old lady who will be pounding her fufu, and each time she'll be pounding the fufu, the person will hit God, and then God will be moving up. And then he got to the place where he is. You know, there's tales, an oral history and stories and all of that. But I think we've come a long way where a lot of things have been documented. Is it in business or in which field don't we have chemistry? We are grateful for this insightful presentation, ladies and gentlemen. With the kindest permission of our Professor Chair, I'd like to do a few more acknowledgements. We are privileged to have in our presence the former Vice Chancellor of Cape Coast Technical University, who is also with the Department of Agric Engineering, University of Cape Coast. He's in the person of Professor J.D. Owusu-Sechere. Shall we acknowledge him? Thank you very much, Prof. We have Dr. Daniel Boyson. He is with the Department of Biochemistry, University of Cape Coast. Shall we acknowledge you, sir? Thank you so much. We have representatives from the Ghana Water Limited across the length and breadth of the country. They are here in their numbers on regional basis. And I think it is all within the context of the old regional basis, maybe not necessarily the current 16 that we have. 10 of them, we have their list here and would like to acknowledge them. We have Mr. Moses Abeku Pencil, Ghana Water Company Limited. ATMA is Accra, Tema Metro Area. And he is in charge of the production region and the regional water quality manager. He's here with his team. Shall we acknowledge you, sir? So much. Ladies and gentlemen, we also have John Sobobiri, Senior Water Quality Assurance Officer, Ghana Water Company. Shall we acknowledge you, sir? Thank you. Manuel K. Tete is the Regional Regional Water Quality Assurance Manager, Eastern Region. Thank you. We have Mr. Thompson Nathaniel, Regional Water Quality Assurance Manager, Water Region. Thank you very much, sir. We also have Cletus Dieku, Regional Water Quality Assurance Manager, Upper West Region. Thank you, sir. Mr. Adam Yakubu is the Regional Water Quality Manager, Ashanti Production, and his team, they are here. Please, shall we acknowledge you? Thank you so much. We have Mr. Evans Atimbiri, Regional Water Quality Assurance Manager, Upper East Region. Lawani. Good. And I have my Pro-Vice Chancellor from CK Tedom. If he were here, I would speak Kasim. Kwetamo, Kogarako, Indianani, Yezuraura. Yes, man. People understand me, and I don't know, am I lying? You know, the first thing I learned is Amave Abolosongo. Do you know what it means? I'm going to my girlfriend's house. That's the first one I learned. Okay, thank you very much, ladies and gentlemen. Professor Chair, I'd like to also acknowledge the schools that are here in our midst, leading Wesley Girls, I beg your pardon. Hello. 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 Hello? Hello? Yes. Hello? Thank you so much. Technical team. Hello? 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 Okay. I hope you can hear me loud and clear. Yes. So I'll continue with the acknowledgement.
Hello, hello. Hello, hello. Hello, hello.
Hello? 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 Hello?
Hello.
Hello? Yes, thank you so much. And there's some good news for the schools that came. There is a chemistry book, a very concise chemistry book for the purpose of effectively studying chemistry and passing with flying colors. And Dr. Isaac Siama has a copy each, or should I say a copy for each of you that came, every one of you. Okay, all the schools. So we have also Holy Child School. Yes, we have Holy Child School. And when I was at Oga School, I used to come to school, your school, several times with my boys. And I was patron for EDU. One book for one school. Asamaba. One is on the lighter side. This one is on the lighter side. Please, nobody should put me on record. Where the man can hear kura manual from basa basa basa. Okay, so yes, I was saying that when I was mostly Holy Child, and I was patron for Child Rights Club and DDW, and my boy, they would not want to leave. They would not want to leave after the program. And you know what they used to do, right? They'll be taking numbers and addresses and all of that. And I'll be chasing them all over the place. It was a very hectic task coming to your school all the time. But we are privileged. Yes. We are privileged for your presence. You are being led by your tutors, Mr. Albert Ishen, Miss Gifty Asarbafo, Miss Celestine Dombo, Miss Jennifer Sam, Mr. Emmanuel Bento, and the almighty evergreen Mr. Ephraim Day, the HOD for Science Department. Mr. Day, Matthew, thank you. Yes, and then we are privileged to have in our presence Lieutenant Colonel Tahiru, Commanding Officer, Base Ammunition Depot, Explosive Ordnance Disposal. Explosive by chemistry room. Okay, Commander, you are most welcome. We are grateful. Ladies and gentlemen, I think I've done a lot or enough of the acknowledgements. Would have to move on because we are far behind time. And this was something we should have done a bit earlier, but we decided to jump that protocol. we would want to have a few remarks by the president of Ghana Chemical Society in the person of distinguished Professor David K. Give it up for him. Thank you.
Hello. I hope the mic will be put in shape, please. In fact, much has been done, much has gone on. I'll paraphrase my speech so that we don't waste so much time. As the president of the Ghana Chemical Society, I welcome all of you to come to the ancient city of Cape Coast to be part of this memorable occasion today. Indeed, you fraternize, you make friendship, collaborate as you are here. I'm so grateful that you made time to come to be part of today's ceremony. The theme for this conference, Chemistry, Making the World a Better Place, is much, much more needed in Ghana today than ever. Where in this country, gold is being mined in each person's room and then in rivers, where Ghana water is being polluted, where everything is in disarray in this country. I don't know where we are as far as the SDGs are, where Ghana stands today. So this is a time for us to make Ghana a better place as chemists. Everybody. And I believe Professor Dakwa has shown us the way, what we can do to make life better in this country. There's something I want to share among chemists. Now, with the Pharmaceutical Council, every drug you buy must come with prescription before the drugs are delivered to you. We are in a country where people who sell agrochemicals have no knowledge at all about chemistry. We are in a country where one can go and buy acid, a lady can go and buy acid and go and pour it on another lady without any prescription. I'm paraphrasing, I don't want to go to the lengthy speech. We are in a country where women can go and buy Sudan dye and put them in red oil. I think it is about time that we get laws that will only allow professional chemists to take care of these chemicals that I'm talking about. We should have legislation that will allow, as it happens to drugstores and what have you, for every agrochemical or chemical shop to have a professional chemist. I had in this country. In mining, in the mining industry, mercury has been sold for years and centuries. You don't know where the mercuries are sold. You don't know where they come from. What is even worse is that we are using cyanide to treat gold in this country. Who takes inventory of how much cyanide comes into this country, how much of it is used, where do we keep the rest? We are sitting on a time bomb. It is time for chemists to speak out and demand what is due us. Create jobs for our chemists, the young chemists and the old chemists. That these things should be streamlined. And nobody can sell chemical in this country without professional certificate. Unless we fight for this, nobody will fight for us. And so as chemists, let us think, because the agrochemicals that come, sometimes they are to be used on have we have different types. Hello. But the chemicals come anyhow. You go to them, oh, this one is good, condemn. This one is this one is that. As a nation, we should even look at the chemicals that are coming into the country. Because after killing the pest, the rest get into our water bodies. And Ghana Water Company is confronted with a way to remove them from the water that we drink, which is very difficult. What are we doing to ourselves? Now, the theme, making chemistry making the world a better place, is very paramount. What about our chemical educators? Now, chemistry has become a stubborn subject in this country. It's become a no-go area. Every student is run away from chemistry. As a chemical society, as a professional body, we need to think about how we can make chemistry a friendly subject and make sure that we develop interest in this subject area so that we can bring more young ones into the profession. I can assure that chemistry is the easiest subject amongst all the science subjects. In physics, you have to state several assumptions. And once you forget about one assumption, you are out of the place. Chemistry uses formulas without assumption. Why is it that our students are run away from chemistry? So for chemistry to give us a better place, we need to have a better chemical education. One other thing that as a professional body we need to know is to engage the community. Let's have a lot of engagement with our community. In this country, you see products being sold out and it's spread on the open sun. When we went to secondary school, I remember you could, this methylation, chlorination of methane, you remember? You know that thing, it's just through the photolysis. And so when you leave things in the open in the sun, you are causing a chemical reaction. And the product in there is not the same as the original product that is supposed to be given to us. We as chemists need to sit up and make sure that we engage the community to educate them on the better way to keep this product and what we have to do. It is our duty. In fact, it's only the chemists that can make the world a better place. You can take me on. But from what Professor Dako has just given, it is only the chemist who knows that the food you are eating is not poisonous. It's only the chemist that can tell you that the water you are drinking, they've taken out all the heavy metals from it. That can test you when you go to the lab in the hospital. Like Professor Dako said, the best doctor should be a chemist. The best medical doctor should be a chemist. And I believe everybody should learn chemistry. Because every day you come into contact with several chemicals. The drugs, the toothpaste, the food, they are all chemicals. There's nothing that doesn't contain chemical under the sun. And God is the best chemist. And so we have no excuse. We have to make the world a better place. It is bestowed on us, you and I, to find a way to make sure that Ghana is a better place. Everything that you are using, the spectacles, the glass, we get them from those sand. Everything. The chemists can change everything to something else. Why can't we generate interest in chemistry for our students to study chemistry? Rather, we are just pushing them off. You come to our department and chemists, we have the least number of students. It's so surprising. that this wonderful subject, people don't want to do it. But we have a role to play as a professional body to make sure that we make the world a better place. With the SDGs that they enumerated, the 17 or so of them, none of them is there without chemistry. Have you taken notice of that? None of them is there without contribution of. And so I just want to welcome you and alert us that we need to do more. We need to have laws that will protect us. We need to have ways where we can incentivize the teaching of chemistry and then make sure that our students develop much interesting. So on that note, once again, to a wonderful environment for the 20th conference of the Ghana Chemical Society. Thank you very much for your attention.
Thank you very much, distinguished Professor David K. Suman, the President of Ghana Chemical Society. We thank you. Yes, I said earlier I have a few questions. I hope there'll be an opportunity for our keynote speaker to address them, especially on the back of what Professor Suman has also said. But ladies and gentlemen, it's my privilege to acknowledge the Western Regional team led by Ms. Gifty Mensah, who is the representative for the Regional Manager, Water Quality Assurance, Western Region. She's here with her team. We thank you for your presence. Yes, we are very gender sensitive. When Prof was giving some of the examples in relation to what acid, for instance, could be used to do, if you go onto the internet, you would see a very beautiful lady, and this story happened somewhere around Atonsu in Kumasi. A young lady who was in senior high school, Form 2, who was going out with a gentleman. And the gentleman wanted to engage the lady in a covenant, a blood covenant. And the lady said she was not ready for that. And so she started running away from this guy or avoiding him. And the guy felt jilted. So he, contracted somebody. And they went and poured acid on this girl. And if you see the girl's picture then, and you see what she's become now, you will be very sad. Okay? So, in as much as women use it on their men, men use it on their women. Yes. Or should I say yes, the men also use it. Acid bath and the rest. In fact, even for assassination purposes. Somewhere around 2015, 2016, thereabout. There was this Upper West Regional Chairman of the MPP, Adam Mahama. Upper East, I beg your pardon, who was acid bathed by some assailants. Some names are mentioned, I don't want to bring it here. And the man died, sadly. But my concern has to do with the usage of weedicides in our communities. Professor, keynote speaker, when we were kids, cocoyam, you could keep it for as long as you wanted to store it for later usage. In fact, the older it got, the sweeter it became. Cocoyam. Mankane emu yasi emu aburu. Ena na yede. Ode ye mankan mpo empo ye friend mpo akaw. De. Ene cocoyam okoto biguo, like you buy cocoyam, you keep it there, and it rots. Cocoyam rots. So one time I asked, what happens? And then they say, the condemn that they use on the land seeps into the soil and then destroys the cocoyam while it is in the soil. How are we dealing with these difficulties? Like Professor Suman said, the usage of these chemicals. With your kindness indulgence, the last time, Professor Chair, I was at Akrokeri College of Education. We're doing a sandwich program organized by University of Cape Coast. And a young lady was using this weedicide around. No protective clothing. There was no protective clothing. Hello? 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 Yes. Hello? 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 Yes. There was no protective clothing. No boots, nothing. No nose mask. There was virtually nothing. So I called her and I said, my dear lady. And then the machine was dripping, and she was soiled. The clothes she was wearing were all wet of the chemical. Why she protected clothing? Why you're washing? And don't do that. You're a young lady. And I was trying to educate her on the potential associated with the exposure. Okay? Especially when you have to do with skin exposure of the chemical. Then there was a man who was a student. I understand they used to call him Nana, like he was a substitute in his community where he came from. He was a student, a teacher, a professional teacher. And who said that he
Hello, 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 hello.
older than me, but at least he was my student. I said, you are ignorant. At least Google never lies. So I Googled the effect of exposure to this weed. And we saw that potentially it could even see in young ones when you get exposed to it. So please, we have a lot of work to do as chemists. The ignorance out there is so much, and I wonder what that man does with that chemical in his farm. You can imagine. Ladies and gentlemen, it is time for us to take the closing remarks from our chair, and you would agree with me that we've done a good job.
Hello, 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 hello,
Our chair, Professor
hello, 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 hello.
Hello, hello, hello,
Hello.
hello.
Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. hello, hello. Hello, hello. Hello.
I wish they would have refused and asked that for the next 20 years, rather come and sponsor our people to get knowledge on lithium and be able to use the lithium. But unfortunately, that will not come in place because the government has already given them the nod to mine. But all what they have to now do is to have tete-a-tete with the community and agree on compensation so that they can leave them land for them. So the supply chain, he mentioned that we really need to be there. And he looked at lithium, which I've already talked about it, that is right here in the country. And again, project, we are sitting on gold, but we don't know we are sitting on gold. I'm from Sopon. I didn't know lithium was very close. I always pass there, go into the forest, and then go and pick some mangoes or pear, not knowing I was working on lithium. So still, Prof, we still don't know what we have. But anyway, the Awoya village, they are very happy that they will have some compensation. Now, towards this lithium aspect, you're looking at energy storage, and as Prof said, we need large energy storage systems. And he gave examples, and one of the examples that really caught my eye here was this flow battery system. I took a good look at the picture. It looks very good, Prof. Thank you. And he provided a beautiful diagram on how vanadium flow system has been incorporated. And Prof, I also read that now they are looking at sodium as being part of energy storage chemicals. Okay. He also talked about how we could achieve this if we're able to get good energy storage systems, which is true, which Prof, I go with you, I'm a physicist. Because if we're able to do that, we could wean off a lot of villages from the national grid, because they have their own backup system, which they can use to provide electricity for them. Because most of the villages, we all use the electricity from the grid only for light and listening to radio. And so if we wean them off, I think the industries can get enough power to produce. So he also talked about chemistry being one that can save humanity, which is true, Prof. Because currently, as we said, we all need energy. And we are all living on agriculture. Everybody has taken something this morning. Even the air that we are breathing, it's all chemistry. Oh, Prof. Prof is giving. I'm learning some chemistry. I hope you're also doing the same. Right. He also talked about the usage of petrol. And he said that even, and it's true again, we've moved from leaded to unleaded, and which is a way of saving our environment from these volatile compounds. And for those of us who are using vehicles, most of the vehicles that are coming now, they've written on it, unleaded. So if we buy leaded fuel into our vehicles, we see the cars not performing well. So Prof, on this issue on energy, I think it's something that I believe that the young ones who are coming, you have a lot of research to work on, because there are a lot of things we can do on energy. And also, for you to know, we've now started a school of sustainable energy, which I believe that will be dealing with a lot of energy-related issues. For power generation, Prof also talked about for us to look at cleaner sources of energy to save our environment. And even this, he also mentioned that we also need to be very efficient. So we need to come out with cleaner sources of energy, and also they should also be efficient. He also talked about that there are certain gases that are also critical to sustain life. And he talked about the green hydrogen energy project in Africa. And Prof, for me to go back to this, I will say that I was very happy that you showed that there's this green hydrogen project, which is in Africa, which is being done here. And I'm so enthused about it, because some 25 years ago, I met one professor. Let me look around. There's no white man here. Okay. And this professor said, "You Africans, you've not done any chemistry." And I said, "What do you mean?" So, okay. Well, the only chemistry you've done is that you've managed to ferment a stem of a plant to produce alcohol, that is palm wine. But I was sad. This is 25 years ago. I was sad. So when I saw what Prof gave out, I was happy. And I said, "Oh, at least we are part of the chain now. They can't tell us that we are only brewing alcohol." And for the first time, I quickly understood the word pyrolysis. Prof, thank you. So I didn't miss the cake. So it's not mystery to me. Thank you, Prof. He came out to the question. He said, can Ghana take advantage of its natural gas? And he also explained to us that what we are using, as you said, he has been told that it is not methane-based. And so, Prof, thank you. Because all these things we don't know. We just go and buy them, and then we switch it on, and then we are using. Thank you very much for bringing us in. And that he also gave a good account on the possibility of getting this out of turquoise hydrogen, which is also a good thing for us. He also talked about the importance of ammonia and its hydrogen as a hydrogen storage molecule. Thank you. Most of us, when we were we only knew our ammonia at something, smelling. But now he's telling us that we can get something good out of ammonia. Thank you very much, Prof. I had a friend who were calling him ammonia. I hope you understand why we're calling him ammonia. This gentleman would never like bathing. Right. He also talked about the research that he's been doing, and then he mentioned one of them that they're able to convert, that is looking at acid-base research, looking at carbon dioxide being changed to methanol, alcohol. I got interested because I saw OH. I saw it. And colleagues who know me will understand why I said OH. It's a good stuff. Right. And he also talked about changing carbon dioxide to liquid fuels, which he emphasized on the fact that fossil fuel is going to run out for sure. And as such, there's a need for us to look at alternative energy sources. An example that he gave, which we have in abundance, is the biomass. And that if we get our processes right, we believe that we will make good use of our biomass. We should be able to produce enough energy for ourselves. And he showed some photos and some other research that is being done in his village that is all this available. So the young ones, I'm talking to my Wesley girlfriends here, there are a lot of research that you can come and do when you come to the university. So please learn hard, take your chemistry serious, so you can come to help us to develop our biomass energy processes. He also talked about the development of second generation biofuels. And again, still on biomass, instead of the fossil fuels, which is giving us a problem in the environment. And that he believes that if we really take a critical look at the biomass aspect as fuels, that will really help in also for clean environment and also an easy way of we controlling our energy source system. Not to say much, as I said, we all listened to him. So I'll conclude here and say that finally, he concluded by saying that let's do things that are sustainable for the future of our country and the world. And I believe, if you share that with me, I believe that truly, the team that they put there, that chemistry can make the world a better place, is very true. Let's give him a clap for that. I wish I was starting my education again. I would have taken chemistry more serious. So once again, ladies and gentlemen, thank you very much for coming, and thank you for coming to listen to our great speaker. Thank you.
Let's do it one more time for our chair. Professor Moses Jojo Egan is the provost of College of Agriculture and Natural Sciences, and he stood in for the Vice Chancellor, Professor Johnson Yakubu, the Vice Chancellor of UCC. We thank you very much, ladies and gentlemen. We have finally come to the end of the program, but just before we leave, I'd like to acknowledge the Northern Regional Manager, Water Quality Assurance, Mr. Al-Hassan Suleiman. Please, shall we acknowledge him? We thank you very much. And we also have the Regional Chemist, Ghana Water. They are here, the Regional Chemist. We acknowledge your presence here. We thank you very much. Ladies and gentlemen, I'd like to invite Dr. Isaac Siama to come with a few announcements. Thank you.
Thank you very much. Good afternoon, everyone. Please let's make note of the following. After the vote of thanks, we're all moving out there where we're going to have a group photograph. And after the group photograph, we're going to go for snack. Now, for the snacks, we want our students. Our students here means UCC students, chemistry students, or other UCC students who are here with us. We want you all to go to the canteen where you'll be served your snacks. With our dignitaries, your snacks will be packed and delivered to you at your cars. And all others, we're going to have our snacks in the corridor. The Ghana Water, our Wesley Girls and Holy Child students, we're going to have it in the corridor. Right after that, we're all going to come back here and start with the plenary lectures, which will be followed by a panel discussion. You saw that distinguished Professor Isuma was taken away and he started going into the panel discussion. So if you want to hear more, let's all hurry back here where we shall listen to 2 lectures, and then after that we shall have a panel discussion where we can all contribute to how chemistry can make the world a better place. Thank you very much.
Thank you very much, Dr. Isaac Siama. He is also with the Department of Chemistry, and he is one of the key planners for this program. I'd like to invite once again, for the vote of thanks, Dr. Mrs. Samira Ago Wananu. After the vote of thanks, we would have the closing prayer, and we are privileged for this gesture to be done as by Professor J.D. Owusu-Sechere, former Vice Chancellor, Cape Coast Technical University, and also with the Department of Agric Engineering here at the University of Cape Coast. He'll be giving us the closing prayer. So shall we have the vote of thanks now? Thank you.
Just before that.
Okay.
Just before that, it looks like we are a little bit behind time, so I want to plead with all of us that we take our snacks and we are back here by 12:30. We're going to do the photos and everything back here by 12:30 to start with the next session. Thank you very much.
I'm sincerely grateful for the opportunity to give the vote of thanks. We started with our Father in heaven, and so it is right for us to thank him for bringing the program to a successful end. We are also grateful to the chair for the occasion, our provost for CANS, Professor Jojo Igan, for steering the affairs to a successful end. We also thank all distinguished members and guests who came from far and near to grace the occasion and make it a very successful one. We also thank our keynote speaker, Professor James Dakwa, for his insightful presentation for the day. We also thank the staff of Ghana Water Company for heavily representing here. Thank you so much. They came from all the 16 regions, actually. So we have Central, Western, Eastern, Bono, Upper West, Upper East. They are all here. Thank you so much for representing. We also thank this is a mistake, I'm sorry. I should have thanked him earlier. The registrar for the university, Mr. Jeff Onyami, for representing and also staying throughout the program. We thank all senior members from all sister departments from the University of Cape Coast for also attending this opening ceremony. I can see members from chemistry, biochemistry, and physics all represented over here. We also thank the senior high schools represented, Wesley Girls and Holy Child. Thank you so much for coming and sitting throughout the ceremony. We also would like to say a big thank you to Royal Society of Chemistry for sponsoring and also their representation. And Elzevia, we thank you for staying and also sponsoring this conference. Then last but not the least, we thank all UCC students, as in from the department, who have played various roles to make this opening ceremony a successful one. We will also want to show appreciation to the LOC for making sure that this ceremony became fruitful. And all those who are playing all the roles at the back, the technical team, thank you so much. We hope to meet back here at 12:30 to continue with the program. Thank you.
Yes, and whatever we did here was live on TVUCC. And we thank the team from ATL-FM and TVUCC. We are grateful for your presence. Ladies and gentlemen, shall we have the closing prayer to be delivered by Professor J.D. Osusechere? Thank you.
Sankofa Yentri. I was staring at her, but I guess I was tense, so I didn't even acknowledge. Please, we couldn't have had this venue for this program without the help of the Dean of School of Graduate Studies, Professor Dakwa. Please show appreciation for her. We also thank Lieutenant Colonel Tahiru for his presence. Thank you very much.
Yes, so let me also correct this. We have, for the closing prayer, Reverend Professor J.D. Osusechere. Shall we give it up for him? Thank you.
Thank you very much. If you actually want to use titles, I'm a right reverend professor. And just to others, I actually came to sit in to support my brother, and you've dragged me to come and offer a closing prayer. And after this talk, I'm wondering what I can say to God on our behalf. Well, I believe some words will come for us to give to God. Shall we rise up on our feet? And then shall we pray? Our Father in heaven, we give you praise. Indeed, you are God, and there is none before you, there is none after you. Creator of the heavens and the earth, we give you thanks. Thanks for our lives. Thank you for health. Thank you for every good thing that you freely give unto us. Today we have heard that chemistry can make the world a better place. We have been told that we need to study chemistry. It is you who is behind all knowledge. We ask for grace for us to be able to acquire the knowledge in chemistry that will help us in our lives. The knowledge that will help us to contribute effectively to the development of this country. We pray especially for these young ones who have come from the secondary schools. We ask for special grace for them, even in their schooling and in their education, that in all that they do, they will acquire the requisite knowledge in chemistry. We commit every life here into your hands. May your hand be upon our lives for good. May you show us mercy in every way. May you fulfill that which you have said concerning our lives. Preserve our lives and receive glory in everything that we do. We thank you and we bless you. In Jesus' name we pray. And all of us shall say a big amen. Thank you very much.
Thank you so much, Right Reverend Professor J.D. Owusu-Sechere, former Vice Chancellor, Cape Coast Technical University, and he's also a proud member of a distinguished member at that, and he's also with this university. We thank you for your presence. My name is Paulo Foria Manfo. If you love it, call me the monkey in the chair. I have been your MC, and we are still around. The conference will be continuing after this session. Thank you. See you again. Enjoy the rest of the afternoon. Bye-bye.